Hi there! Can you think of a way to define a derivative of a function of two variables? Let's first remember what the derivative f prime means. Given a function f of a single variable x, the derivative of f in x is equal to a is defined as the limit of the difference quotient as a tends to 0. The quantity f prime of a is equal to the rate of change of the value of the function f when x increases starting at a. Geometrically, the quantity f prime of a is equal to the slope of the green tangent line to the graph of the function f at the point a f of a. Now suppose we have a function f of two variables, say x and y, and let ab be a point in the domain of f. How do we describe the rate of change of the value of the function in the point ab? Both variables x and y can change independently. So how can we define a derivative for a function of two variables? The two so-called partial derivatives of f in the point ab are defined as the rate of change of f when xy moves away from ab in the x direction and in the y direction. Let's have a look at the first scenario. When xy moves away from ab in the x direction, the function f is f of x and y is in fact a function of one variable only, because y is equal to b is fixed. Let's note that function by p. So p is the function of x, defined by p of x is f of x and b. The partial derivative of f with respect to x in the point ab is simply defined as p prime of a. Instead of p prime a, we use the notation f subscript x ab for this partial derivative. Using the formula for the definition of p prime of a, we thus arrive at the formula shown here for the partial derivative with respect to x. What is the geometric interpretation of the quantity f subscript x ab? Well, if c1 denotes the black curve, which is the intersection of the graph of the function, and the yellow plane with equation y is equal to b, then fx ab is equal to the slope of the tangent line to c1 at the orange point ab f of ab in three-dimensional space. Similarly, we could be interested in the rate of change of f when xy moves away from ab in the y direction. Then we would consider the function q defined by qy is f of a and y, which is a function of the single variable y. The partial derivative of f with respect to y in the point ab, denoted by f subscript y ab, is simply defined as the derivative of this function q in the point b. Geometrically, f subscript y ab is equal to the slope of the tangent line to the curve c2 at the point ab f ab, where c2 is the intersection of the graph of the function and the plane with equation x is equal to a. In single variable calculus, you have learned several rules and techniques for computing the derivative function f prime of a function f of x. In class, you will learn how to compute the partial derivative fx and fy in a quick way. See you then!